Our next speaker is named Jing Chao. She is a professor of statistics at the Department of Statistics and Data Science at the Southern Methodist University. Her most recent research focuses on the combination of statistical learning and machine learning algorithm in sentiment analysis. And today she will be talking about decoding the information in wine review text. The floor is yours.
There has been a long debate on whether wine review is a piece of garbage or it's useful. Now, as a statistician, we collect the data to prove this ourselves. So we look at the data published in one of the most respectful wine spectator, the journal, and we script 10 years of data with my graduate students. So let me give you a quiz. I'm a teacher. I like to give quiz. So can you tell very briefly which one has a better review? Well, when I started, wine review language is not everyday language. It's something to be encrypted. So now let me tell you, because I don't want you to feel bad. The first one is just the okay wine, and the second one is an excellent wine. So in order to see this, it falls into what is called sentiment analysis. This is a very useful field. If you do online shopping, everywhere is filled with sentiment analysis. Do you like this? Or you have no feel about it, or you hate it? So this is sentiment analysis. Now, we look at the data, okay? And then this is a piece of sample from the data. And the data has ID, and the rating, if you know wine rating, it goes from 80 to 100 yearly. And then this is their raw text review. Now, for demonstration purpose, we just dichotomize rating into above or equal 90. That means a positive sentiment, or less than 90. That means a not that positive sentiment. And then we run this machine learning algorithm, CNN, bidirectional long short-term memory model, BERT model. Now, without getting into the technical detail, you will see the model, the machine learning model, give you very good result in terms of classifying whether it's a good wine, or below 90 mediocre wine. And then if you just run logistic regression, well, the accuracy is much lower. It's only less than 80%. Now, this tells you that machine learning, it can really retrieve information from text analysis. But as statisticians, we want to know why those AI or machine learning model can give you a good result. It's like you go into a doctor's office, right? You don't feel very good, or doctor tell you you have a stomach bug. But you don't stop there. You want the doctor to explain how this doctor arrives at this diagnostics. So we want to know why, because machine learning is like a black box. We want to hack into the black box and explain to us how this machine learning model can arrive at this very impressive accuracy in classification. Okay, so this is a little bit technical. In order to do that, we need to first transfer text into data, because most machine learning models, they use numerical data, not really raw text data. And then the second component is called multiple instance classification. I will explain a little bit later. And the last one is the attention mechanism. Yesterday, we have a splendid talk about attention is all you need. I'm going to use that too. And together, you will see we will give you a very interesting result at the end. So first, how to transfer text into numerical data, we use what is called word embedding. So word embedding is to use a vector to describe the information in the word. So for example, just to give you very intuitive understanding, cat, kitten, dog, houses. So the first maybe tell you how it is associated with a living being. Okay, and the other dimensions tell the other directions in the word meaning. So by using this, instead of using one hot vector, we can look at the relationship between different words. So for example, cat and kitten, they're close. So they're located very closely in this word embedding space. Well, houses is not a living thing. So it is far from those living beings. And this is how we transfer text into data so the model can use it. The second is called multiple instance learning. So this is one kind of machine learning. Give you an example. So suppose one person's keychain can open a secret room, and the other person's keychain cannot enter a secret room. But you don't know which key it can open the room. You only know this collection of keys together, whether it can open the room or not. Though this is called multiple instance. You don't know whether each instance is a successful instance or not, but you know on the bag level, on the collection level, whether it can open the room or not. So this is useful because it kind of gives less demand on labeling the data. Instead of labeling each key, you only label the keychain. And then the question is, given another keychain, whether this new keychain can enter the room or not. So this is multiple instance learning, and we'll see how it is connected to sentiment analysis. So this has a lot of application in real world. Now let's look at how to decode the information in one text. When we read the one text reviews, something strikes us is, well, for this very first one review, it has a rating of 95. And then intuitively, you see it is surrounded by those wonderful words: amazing, enticing, wonderful, elegance, grace, persistence, so on and so forth. Now, for OK wine, it has some words like nice, bright, crisp, complex. It is good sentiment, but it's not as strong as enticing, as amazing. But these words are, we call it sentiment words, but also carry different level of sentiment. On the other hand, if you look at pretty bottom wine, only with rating 82, you don't really have those strong sentiment words, right? So those strong sentiment words is an indicator how enthusiastic the wine judges feel about different wines. So make the connection. What is your bag? Each bag is in one review. This paragraph is a bag. What are the useful instances? Sentiment words. Those are the deciding instances that can open a room, that can tell whether wine is good or not. If you have those sentiment words, that means you have the useful keys in the keychain, but you don't have the sentiment words, then this keychain cannot open the secret room. So you can make the connection there. Okay. So technical details, let's skip that. And then what we do is to build a model that first identify what words are the sentiment words. And then given a word is a sentiment word, then we measure how strong the sentiment there is. So the two pieces together can really tell you the whole level of the sentiment in each one review. Okay, so this is what we have. Now, each word, first we tell, are the sentiment words or not? 1 is sentiment, 0 is not sentiment. Also, we have a numerical measurement of the sentiment that's embedded in each of the sentiment word. Well, can we do a good job here? The good job is to measure it to the machine learning accuracy. Now, if you recall the machine learning accuracy, we have good, bad, but this model cannot really do that good a job. So what it does is it does not really take this context into consideration. Now, what do we see here? A kitten, right? And then you don't see what is the background, the wall, the carpet. So that is because each one of us only have a limited attention wavelength. So we only focus on what is important and not really focus on what is not important. And then what we do next is to build this attention mechanism into our data. That is, instead of looking at each word individually, we also build in the context around each word. Okay, now this is the technical detail, and then each story has a climax. So here comes the climax of the talk. Now here we look at the data, okay, and then we can produce the top sentiment word. Oops, what did I do?
That's a real climax.
Okay, thank you. I always like technical guy solve my dilemma. So here we have those sentiment words, and then most of the words make sense, but there are some words that's not straightforward, like stained. Stained usually in everyday language is not clean, right? It's stained. But in wine review, it's a good word. Stained means, well, it's heavy, it's thick, it has complexity, it has layers of taste. Carpet. Carpet is not sentimental word in everyday language, it's carpet. But in this wine review language, carpet means, well, it's thick, it's layered, it's complexity. And then you have a cascading, you have a fabric, it has these different words that you won't recognize. They are strong sentiment words in everyday language, but they are sentiment words in wine language. Now, the next is the bottom words, negative words. And then most of the words make sense, but there's still something that's quite intriguing. Quick, hearted, light-hearted, straightforward, easygoing, breezy. Now, if you look at those words in everyday language, they're pretty good words, right? Easygoing, straightforward, breezy. But in wine review language, they're not, because the wine experts, they're too polite to say your wine is not good. It's just, it's too simple. It's too straightforward. It does not have complexity. It's just too easy to be appreciated. They want something mysterious, something you cannot decipher at first taste. So through this, we learn the language from wine review is a little bit different, not a little bit, quite different from everyday language. Now, if you can master the key, actually you will have a better idea how to decipher, how to decode the message in wine review. Now, I want to end this by comparing it to ChatGPT. It's on everybody's mind. Okay, what is the difference between your model and ChatGPT? Actually, we try to use ChatGPT to decode the information. ChatGPT only gives you a very generic description. Oh, it's pretty positive. And it does not give you this very granular, okay, I did again, very granular kind of information about the numerical. See, what we can do is not only see this lush, beautiful, gorgeous, linger beautifully. We know this gorgeous has a strong sentiment than linger. Not only we can see which words useful, but we can quantify how strong a sentiment it carries, and then give us a better idea about how to interpret this wine review data. Okay, that's all. Thank you so much.
Thank you. Thank you for the interesting presentation. I've done a lot of econometric work, but not with machine learning. It's with structural econometrics, which is sort of the opposite end of the spectrum, perhaps. And so, despite your excellent presentation, machine learning remains a black box to me. So it's a naive question I'm going to ask you. I noticed you had those 3 different reviews and different kinds of language. You were looking for the strength of the sentiments, positive, negative. What I'm wondering is whether or not there is some way that the work you're doing controls for the fact that there are reviewers who just love everything and use extremely strong language, and we know who they are. They're also giving 95 points or more to every wine, but that they use glowing language. There are others who maybe do give a high rating, but they're just more modest in terms of the type of language they use. So are you somehow controlling for the person who wrote the review?
Yes, that's definitely a great question. Actually, we use this to decipher who is the author. So each author, each reviewers, they have their own vocabulary. So one I noticed like to use rose, the taste rose on and on. So roll, R-O-L-L, will be a magical word for that person. So we can use that to control who the person is, and also each person have their own preferred range of rating. Someone use 80 to 90, someone use 85 to 95. Yes, the answer is definitely yes. And I also want to say something about black box. One advantage of our method is it's simple. So it's a white box because everything, those parameters, they're linked together. So that is the beauty of connecting. This is a happy marriage. of statistical modeling and machine learning. So we join the best of the two sides. Statistical learning structure give you the transparency, and then the attention mechanism from machine learning side give you the efficiency. So for me, I do see a happy marriage is the best marriage between these two sides.